Today we are going to solve radical equations. Now there are 4 steps to do this. We have to isolate the radical, which means that we need to get the radical and anything that's underneath it all by itself on one side of the equation. There can't be anything outside the radical. The next thing we are going to do is square both sides. Now when I say square, that's because most of the equations we do are going to be the square root functions. But if it's a cube root, you will cube both sides. If it is a fourth root, you will raise both sides to the fourth. Then we are going to simplify and solve. And then the step that you all love to skip is we have to check it. Because with radical equations, you have extraneous solutions possible. Now, an extraneous solution is a solution that the algebra process gives us, so we're doing everything right, and the process says, yes, this is a solution, but when we plug it back into the original equation, it doesn't actually give us a true statement. So we have to check for extraneous solutions because they can happen quite often. So let's look at some examples. Okay, here's our first example. Our radical is isolated because though it has a 5 and an x under it, there's nothing outside of it. So we are going to go ahead and square both sides. Now the reason we do this is, remember, when we square root and square at the same time, they cancel each other out. So the whole purpose of step 2 is to get rid of the radical sign. Now it's just a basic equation. We are going to divide both sides by 5. X equals 20. So it looks like x equals 20 is my solution, but remember, we have to check. So we're going back to the original equation. 5x equals 10, but everywhere there's an x, I am now going to plug a 20. Because that was the solution I got. 5 times 20 is 100. The square root of 100 is 10, and that does equal 10. That works, so this is a solution. Okay, let's do number 2. Okay, so 2 times square root of x plus 1 equals 14. Now here is my radical. There is something outside of it. So I need to isolate this. So I am going to divide both sides by 2. 2 divided by 2 cancel each other out. It gives me a 1. So I have 1 square root of x plus 1. 14 divided by 2 is 7. I am doing step 2 now to get rid of my radical sign. So x plus 1, because remember those cancel each other out, equals 49. Nice simple equation now. X equals 48. But now we have to check it. So I go back to my original equation. So everywhere there is an x, I am now going to plug the 48 from when I solved it. So we have to do what's under the radical first. 48 plus 1 is 49. Now we have to take the square root. Square root of 49 is 7. Now notice I put it in parentheses so that we can remember we are multiplying the 2 and the 7. So 2 times 7 is 14. That does equal 14. So this is my solution. Okay, nice and easy. Let's do example 3. Alright, so we've got the square root of x minus 1. Outside the radical, see here's the radical, we have a plus 4 on that side of the equation. So we need to isolate it. So I'm going to subtract 4 from both sides and get the square root of x minus 1 equals 1. Now we're at step 2. I am going to square both sides. I get rid of my square root sign. So x minus 1 equals 1. So we add 1 to both sides. We get x equals 2. So now we need to check it. Again, we're going back to the original equation. X minus 1 plus 4 outside equals 5. So I'm going to plug in everywhere there's an x. I'm going to put a 2. And now I'm going to simplify. I'm going to simplify what's under the radical first. 2 minus 1 is 1. Square root of 1 is 1. And 1 plus 4 is 5. This does work, so this is a solution. Okay, let's go ahead and do another example. So example 4, the square root of x plus 18 equals x minus 2. Is my radical isolated? Okay, what is my next step then? We square both sides. So we are going to square both sides. Gets rid of the radical sign on this side. So on this side, how do we deal with that?
Would it be like x squared or something?
Yes, we are squaring x minus 2, which means we are multiplying it by itself. So we need to FOIL x minus 2 times x minus 2. Okay, let's go ahead and do that. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Okay, here is where we are doing the simplify part of step 3, the simplify and solve. I'm going to go ahead and combine these two pieces, which gives me negative 4x plus 4. When we did quadratic equations, what did we always set the quadratic trinomial equal to? 0, exactly. So what I need to do is I need to move the 18 over, which is going to give me a negative 14, and I need to move the x over. I hope this doesn't mess anybody up that I'm doing both steps in one. I need to move the 1x over also, which gives me negative 5x, and now I'm going to bring down that x squared in front of it, but that leaves me with 0 on this side. How do we solve quadratic trinomials? We factor, yes. Now, I know it's been a while, but I want you guys to try to factor it on your own. I'm going to give you about 30 seconds. If you're on the video, hit pause, try it, and then come back on. All right, I am going to look at this sign. That tells me that my two signs down here are going to be different, so I'm going to put a plus and a minus. I multiply the first term and the last term to get 14. I need to look for factors of 14. 1 and 14, 2 and 7. Since these two signs down here are different, I need to find factors that I can subtract to give me negative 5. It's going to be 2 and 7. Since the 5 is negative, I'm going to put the 7 with the negative sign. So 7x, 2x. Now I'm going to group. I am factoring out an x out of this first parentheses, and I am factoring a negative 7 out of the second parentheses. Now remember that we're going to check right here. These two parentheses are the same, so I bring it down once, cross those out, and the only thing I haven't crossed out is x minus 7. And all of that equals 0. Okay, so if you remember from solving quadratics, once we have the two factors set equal to 0, we take each factor and set it equal to 0. So I get x equals negative 2 and x equals positive 7, because we always take the opposite sign. Okay? Now we need to check it. So I am going to Check, that's not a CH. Check. My original equation was the square root of x plus 18 equals x minus 2. So I am going to plug a negative 2 in where there's an x. And I get square root of negative 16. Nope, positive 16. Sorry about that. And negative 4. The square root of positive 16 is a positive 4. Does that equal negative 4? No. So this one is extraneous. That's what that's going to look like. I plug in the 7. 7 plus 18 equals 7 minus 2, and I get 25 equals 5. The square root of 25 does equal 5. This works. Oh, sorry. I just realized this isn't my extraneous solution. This is my extraneous solution. Be sure that you mark the solution extraneous, not the check. And this one is my solution. And that's how we solve radical equations.